Hi, my name is Spencer Dunleavy, and once again, I'm a fourth-year medical student here at Columbia. I'm going to show you in this video how to make a couple basic plots that you may want to construct in R. More advanced plots can be made using a variety of functions within the package ggplot2 that you can learn as needed for future projects. The basic plots we'll discuss here include a generic plot by row number, histograms, box plots, quantile plots, also called QQ plots, and scatter plots. We will also expose you to generating maps during the later part of this course. So for now, we're going to import our county health rankings dataset, and as usual, we're going to limit our data to only counties. A really simple way to see the distribution of your dataset can be to simply plot the values by the row of your data frame. This can get you a sense of if there are any clear outliers. The plot function does this for you. So let's look at the number of deaths across counties. Here I use the plot function, and then I specify the column that I want to look at. When I run this command, you can see that there are some counties with extremely high death rates compared to the rest, which typically are falling really close to zero. Well, this includes LA County at the highest, which had over 84,000 deaths in the year that this was collected. The issue with this plot is that we don't have a good sense of the actual distribution. So the best option to initially visualize the frequency and distribution of values in a dataset is usually a histogram. The command hist generates a basic histogram. So let's look at this histogram of deaths by county. As you can see, most of the data is clustered near zero, with a long tail out in the thousands. This gives us a different way to view it than the generic plot we had made at first. But unfortunately, this histogram doesn't actually tell us much about most of the data, because the scale with all of these outliers messes up our interpretation of the lower values. In this situation, we can set limits on our histogram to see just parts of it for better interpretation. Be careful though, this can sometimes hide some data. Here, I'm going to use the xlim parameter to define the range I want to see to just be between 0 and 5,000. I can also use the breaks parameter to specify how many individual bars I want to see. So when I put all of these things into the hist command, as shown here, and I run it, I can see a much more interesting and useful histogram. As you can see, it's not quite bell-shaped. It's not normally distributed. There's still this tail out into the higher thousands, but we can now appreciate a little bit more of the nuance about how many deaths are occurring per county. In general, hist by default tries to give a good number of breaks or bars that help you visualize the data accurately. By default, this is set to 30. But if you play with it, you can either have too many breaks or too few. This can really obscure how you interpret the distributions. So here's an example with too few breaks. With only 10 breaks, it takes the full range of data from 0 to 84,000 and counts in 10 intervals of size 8400. This makes it not very useful to interpret. When I run this histogram, you can see that it basically only gives us 10 bars, and it's not useful for our interpretation. Now, you can also go too many. With 100,000 breaks, it says take the full range of data, 0 to 84,000, and count in 100,000 intervals. In this case, it would basically be of size 1. This makes it not very useful to interpret either. When I generate this histogram, we end up with this weird distribution only counting up to a frequency of 10. It doesn't tell us a whole lot of information. Now let's see a histogram of the percent in fair or poor health. So I will do a histogram, and I will specify my variable. If I generate this histogram, you can see it looks fairly normally distributed, maybe with a little bit of skew on the right side with this tail out for the counties that have more people who are in poor or fair health. But otherwise, this looks approximately bell-shaped. Box plots are another useful way to get an initial sense of the distribution of your data. The command is boxplot. So I type boxplot, and then I specify the variable I want to look at. So now, if you remember from elementary school, a boxplot shows a variety of things. The dark bar in the middle refers to the median. The outsides of the rectangles represent the 25th and 75th percentiles, which means that the distance from here to here represents the inner quartile range. The whiskers help you identify where you might find some outliers. They identify an appropriate range based on the inner quartile range of where you might reasonably find a data set. These dots up at the top are quite high relative to the rest of the data set, and they may be considered outliers. You have to decide if it's appropriate to include them. A cool thing about box plots is that you can create multiple in one single plot. So what if we wanted to see a box plot showing distributions of percent in fair or poor health at the county level and at the state level? So let's go back to our original data set that had both states and counties in it. So I'm going to read in that CSV and define it as the overall data frame. I'm going to define a new column that tells me if the row is a state or county. First, I'll just label everything as a county, and then I will select only the rows that had no data for the county variable. This is the same process we went through in one of the prior videos. Now I will redefine all of the observations that have empty county names as states. So just to confirm we did it right, I'm going to run these commands. You can see I've now identified 3,142 counties in 51 states, which includes Washington, D.C. So now let's create our multiple box plots at once. The first line says that the value to be plotted is percent in fair or poor health. Then the squiggly line signifies that we want to subgroup by the state or county variable. Once I do that, I need to let R know which data frame I'm pulling the information from. So if I run this command, you can see that there are many potential outliers at the county level. But at the state level, all of the data is a lot more compact. There are no real outliers. The state level percent in fair or poor health is a little bit lower than the county level. We can make a lot of interpretations of what this means if we want to apply it to a particular research question. Now, one of the most important things about calculating means, linear regressions, and many other statistics is the normality assumption. This means that for some tests, our data must be normally distributed, or bell-shaped, for the test to be used appropriately. You'll learn a lot more about this in class. Often, we can just look at histograms as a quick check, as we've done previously. But you can also generate a quantile-quantile or QQ plot to see if it is actually similar to a normal distribution. What it does is that it lines up our expected percentiles, if this were a normal distribution, with the percentiles we actually found. So just to show you an example, I'm going to generate a pretty normal distribution. This is beyond the scope of this class, but I can generate a slightly randomly distributed distribution where I have 1,000 data points with the mean of 50 and a standard deviation of 5. If I do a histogram of this, and then I do a QQ plot, you'll see what it looks like if something is actually normally distributed. So I look at my histogram. This is pretty bell-shaped. I look at my QQ plot, and it's mostly a straight line in this QQ plot. When it looks like this suggests that something is normally distributed. So now let's look at a histogram of the poor and fair health variable again. So if I look at this histogram, you can see that still looks pretty bell-shaped. It's not perfect, but it's pretty close. If we want to look at the QQ plot, we can also give evidence about if this is approximately normally distributed. When I look at this isn't exactly a straight line. You can see that there's a little bit of a curve, but it's pretty good. It's not really deviating from this straight line. So I might say it's reasonable to do all sorts of parametric tests on it, including linear regression, calculating means, and standard deviations. For context, I'm going to show you now a histogram and QQ plot of deaths. We already saw that this was very skewed. We had Los Angeles County that had really high numbers of deaths along with other counties. So if I create a histogram and QQ plot, the histogram, as you saw earlier, is not even close to normally distributed if you consider the full range of data. And when you look at the QQ plot, you can see that this isn't even close to a straight line going through the middle of the plot. This suggests that this is not normally distributed, and we should not do tests that assume that the data is in fact normally distributed. So the final major plot we will use frequently in this class is the scatter plot. The scatter plot shows observations plotted in 2 dimensions, showing you potential patterns between these 2 dimensions. Here, we can make a scatter plot using the plot command that we used before. We just have to specify an additional dimension. So let's assess a pattern for poor and fair health and uninsured rates. So I will do a plot where the y-axis will be the percent of people in fair or poor health, and the x-axis will be the percent of uninsured people in the population. When I run this command, it generally looks like as the percent of people in a county are more uninsured, we have more people who are in fair or poor health. So it suggests that having higher rates of uninsurance leads to lower quality of health. So let's look at this at the state level. First, I define a state-only data set. Then I do the same scatter plot as before, just at the state level. I've used a different data frame in this command, but I use the same columns to specify it. When I run this, you can see that there is maybe a little bit less cluttering in this data set, but in general, as the uninsured rates go up, you also have more people who are in fair or poor health. So now you may be asking yourself, how do I know if this is actually a good fit? If I drew a line, would this be reasonably going up or down or what? Well, you will learn the statistics behind this in class during the semester. So now it's your turn. Import the county health rankings and subsets of counties using the code below. Here, you're going to have a county's DF and a state's DF. Now you're going to look at the percent of people in the county that have some college at the county level. Do you think this appears normally distributed? Use a histogram and QQ plot to make your case. Then, at the state level, create a scatter plot investigating the relationship between access to exercise opportunities with the percent of the population with a BMI greater than 30. So variables that you can do this with are the percent adults with obesity and percent with access to exercise opportunities. From this data, you can make hypotheses about how access to exercise opportunities may relate to the level of obesity in a community.